Alright, lesson 2, hydraulic pumping, STP task 551-758-1007, 551-758-1008, 551-758-1012, 551-758-1071. Introduction. Aircraft plumbing is in the stage of the aircraft maintenance for dealing with the mechanical tubing flexible hose necessary to fitting the seal to provide a pathway for fluids, gas for the move between the components on the aircraft, although the text deals mainly with the hydraulic system that can plumbing principles explained here and apply to the plumbing requirements of the field, ventilation, pneumatic periodic stock symptoms, as well as basic similarity with the maintenance personnel responsible for the hydraulic pumping and are usually required to perform the repair and maintenance of all the aircraft plumbing systems. For mechanic to repair aircraft plumbing from the NTO maintenance for the officer supervise the work with effectively, he must be familiar with the material and equipment, the fabrication techniques necessary to repair and install the lines. Part A lesson deals with the identification methods of fabricating the tubes, the content of the components for the hydraulic system. Part B with the use of advantage for the hose and flexibility. Tubing are explained, including the marking, fabrication, installation methods, and storage requirements for these material. Part C describe the different types of seals for the gas to use to prevent leaks with the internet connecting tubes, hose, and the fittings of the plumbing system. Variety of lines. Throughout the lesson, you will see the terms such as the plumbing lines, the tubing, the flexible tubing, the hose used extensively. By the definition, plumbing lines refer to any ductwork used to transfer liquids or gases from the one location to another. Lines may fall into one category, two categories: the tube, rigid lines, and hose flexibility lines. Many materials are used to fabricate these lines. Each one of the offers a different advantage when replacing damaged defective lines. May be an effort to duplicate the original line completely, closely as possible. Under some circumstances, however, the field expeditions requirements of replacement of the damaged line similar with no identical line. Then choosing the west side of the type of the line, use evaluate the following important elements: type of fluid, gas, the lines that conduct with pressure and must operate under the temperatures, must withstand vibration is subject to. Identification of lines. Except for the inlet and the exhaust section for the engine compartment, the plumbing lines are identified as adhesive bands with a different color colored with a particular system to which each line belongs. In any Army 2 type of identification code systems are used. Printing symbolized tape system, the preferably method in the solid color tape system. The alternative method preferred. Some systems use tape bands with two more colors printed with identifying geometrical systems. Name of the system example: these bands shown in figure 2.1. The alternate method is 1, 2, 3 bands, 1.5-inch solid color tape wrapped on the various lines of identification of the color code used when this system is shown in figure 2.2. In the areas near the inlet section of the engine compartment where their tape might be ingested, sucked in, or near the exhaust section where the high temperatures might be burned, the tape suitable paints can form into the color codes figure 2.2 with marking and plumbing lines. Additional white tapes labeled with the pressure drain and return for the color bands for either the code system to identify the lines. These types are also printed with the arrows indicating the direction of fluid flow. This shows the color-coded tape. This shows the color-coded band system. Procedure fabrication techniques with the proper tool for the important selection of the tubing material, repairing, replacing damaged plumbing lines, unless taking extreme care during all phases for the repair finish for the product. Way to the deductive is original. The part to discuss the criteria selected for the proper type of the tubing, correct producing the routing lines for cutting and the bending of the tube, type of the tube fittings, and method of tube flaring installation techniques with the tube repairs the tubes that are not extensively damaged. Tubing. In Army aviation, three types of metal tubing are used: aluminum, alloy, stainless steel, and copper. Generally determine the type of the metal visually. If not possible, mark the tube at 3-foot intervals with the manufacturer's name, the trademark tubing measurement material, and specification number. The tubing is into too small marked in this manner, identifying the attaching of the tag with this information to it. Aluminum aircraft plumbing, the mostly wide with the use of the metal tubing made with aluminum alloy. General purpose of the tubing, the advantage of the workability, resistance of the corrosion, and lightweight. List of aluminum tubing authorized with the Army aircraft is found with the TM 1-1500-204-23-2. Aluminum tubing generally used for the Army aircraft hydraulic system operating with a pressure of 1500 psi below the type 5052. Military specification WWT-7004-4. Because of the workability of the tubing, assembly can be readily fabricated in the field for those hydraulic system operating with a pressure of 1500 psi. Aluminum alloy tubing 6061 and 6062. The military specification specification T7081 are used to process the tubing, and tubing assembly requires special procedures equipment not generally available in the field. Therefore, assembly made for these aluminum must be obtained with the supply chains, the factory of prefabricated parts of those depot maintenance shops. Stainless steel. Tube stainless steel can also be used where the pressure is 1500 psi. Stainless steel must be used outside lines, such as brake lines attached with the landing of the gear strut and other exposed lines that can be damaged by flying objects, ground handling mishaps. Stainless tube times like high pressure aluminum alloy tubing that is difficult to form without special tubes is obtained with the supply chain with the depot repair facility. Copper tubing is primarily used with a high pressure oxygen system. The fittings of the copper tube with the solder on the silver. The copper tubing used with a high pressure oxygen system of 3/16 of an inch diameter or 32 thousandths of an inch wall thickness. Federal Specification WWT 799 Type N low pressure oxygen system used large diameter aluminum tubing filled with aluminum fittings in one case only in case of emergency can copper tubing within the same diameter wall thickness of aluminum tubing be used to replace it. It must be conformed with the Federal Specification WWT 799 Type N steel tubing must not be used to replace the high pressure oxygen system copper tubing because it loses ductility and becomes brittle at low temperatures. Routing of the lines. If damaged lines are discovered, the first step of the repair to determine the cause of the damage is if the caused by shafting the structural member of the aircraft with a poor layout plan. Conditions may be corrected if the line with the defect with the same layout is acceptable to carefully remove the damage and tube the use of the pattern of fabrication of the replacement tube to generally replace the line follow the path of the original line. However, when the line must be rerouted due to the standards that are discussed in the paragraph below. Number of bends. When the fluid flows around the bend, it creates a friction, generally generates heat, and it causes the overloss for the system efficiency. With this in mind, tube layout must always follow the path, with the result of gradual bend. On the other hand, the path with no bends is likely to result in even more problems. First, to cut the replacement with an exact length is virtually impossible. This is going to result with mechanical strain being exerted on the tube when the attaching nut is drawn up on the fitting. Because the greatest amount of the strain is already concentrated on the flare portion of the tube, the result of the flaring operation of the additional strain is likely to weaken the tube beyond the tolerance. Second, if the tube has no bending that cannot flex for the subject of the variation, the lack of the flexibility promotes the fatigue of the tubing metal, makes it more susceptible to failure. With the third and straight line insulation allows no provision of the normal contraction and expansion of the tube caused by the temperature change. Example, the correct and incorrect tube layout is shown in Figure 2.3. Figure 2.3 shows the correct on the left side and incorrect on the right side. Minimum radius bends. The middle of the heel of the bend tubing will always stretch with some extent, but the stretching of the weakening of the tube must be kept within the limits. Radius and sharp bending is permissible for the given side of the tube is designated with the minimum bend radius. If the limit exceeds the metal at the bend over the subject of the rupture under the operating pressure bends with the greater radii with the minimum allowed. Also, is a preferred method of the tube depending on bending of the tools using depending on the bending the operations as discussed later in the section table. Minimum bending radii various types of size of the tube containing technical manual 1, 1500-204-23A. The copy of the table is shown in Table 2.1 on the following page. Table 2.1 shows the minimum bendings radii in steel tubing. Supports are always used in tube layout and limited the sideward movement of the tube due to the pressure surge of the vibration. Maximum distance between the support determined with the tube material to the outside diameter of the rules governing the specification of these supports are found in the Chapter 4T 1 1500-204-23-2 template. If the damaged tube cannot be used with the pattern of the replacement line with the use of the wire, make of the template to do this and the running of the wire between the fittings of the wire. The line must be installed, bending of the wire in conform with the tube layout standards previously described. Tube cutting. When making the replacement of the tubing, the stock material the stock must be measured to cut approximately 10% longer than the damaged tube. This ensures sufficient length for foaming of the flares and small deviations in the bending of the tube to the pattern. An extra length must be cut off before forming the last fair. There are two accepted methods of cutting. The one using the standard tube cutting shown in Figure 2.4, the other using the hacksaw. Other completion of the tube cutting is either the process of removing all residue and procedure. To do this, the ream end of the tube will slightly reflash the entire piece of the tubing through. These methods are discussed in detail further in this text. 2.4 shows the standard tube cutting tool. Standard tube cutting tool, the ideal method of cutting the tube with a standard cutting tool. The tube is slipped through a cutting tool with the right angle of the cutting. The wheel is adjusted against the steel. Take care not to force the wheel against the tube too tightly, as it will force the tube out of the round. While the tube is being rotated, the cutting the wheel feeds must be tightened to a little while each turn until the wheel has been cut through the tube. The tube cutter must be rotated in one direction only. It is handled between a swung in the same direction, opening faces Opening faces when properly used with the two leaves the smooth end of the tube squares when it axis. Hacksaw and cutting the tool is not available using a fine-tooth hacksaw, preferably one with 32 teeth per inch. Since it's difficult to get a good square flush cut on the tube with this method, tube must be filled with the cut and it's made. During the hacksaw cutting and the filling, the tube must be clamped on in tube blocks and other suitable holders, preventing scratching, bending it into a producing 900 cut on the tube end. Methods of tube bending. Tube bending can be done with any one of the variety of the hand power bending tools, regardless of the method used. The object is obtaining the smooth, even bending without flattening and the buckling. Examples of this result is shown in Figure 2.5. 2.5 shows acceptable and unacceptable tubing bends. It shows the perfect bend and a flattened bend, and then shows the kink bend, which is unacceptable, and the wrinkled bend is unacceptable. Hand bending methods. Tube less than 1/4 inch the diameter can be bent with the hands, but take care to work with the bend gradually. For size larger than 1/4 inch of the diameter, using bend tool. However, this tool is only effective with one thin-walled tubing of the soft material. Two common bending tools are bending springs that are used for the matching of the inside diameter ID on the ID of the springs with the outside diameter, OD on the inside diameter of the spring with the outside diameter of the tube. To be bent, the tubing of the insert with the center on the heel of the bend. The bend must be started with the larger than desired. Gradually work down to the correct size of the coil spring out of the structural tank of the tubing wall during the bending of the prevents the tube from crushing the kinking. Roller bending tube. The tool bends a tube to desired radius of area efficiency and consistent with the groove of the roller with a degree scale marked on the outside of the slide bar on the hand to point in the degree of the mark where the tube is to be bent. If you use the tool, the straight tubing must be secured with the tool in the tool for the instant, marking the indicated zero of the degree on the bending of the scale. The pressure applied to the slide the bar bending of the tube is shown in Figure 2.6 of the desired degree power bending tool. The tube bending machines are generally used at the depot maintenance shop, which such equipment proper bendings can be made in the tube in large diameters, hard materials in the production of tube benders, example of the type of the machine. Alternate methods. Tubing has 1/2 inch or larger outside diameter. The difficulty of bending with a hand tool. For this tubing, power tools must be used whenever possible since they have an internal support that prevent flattening and the wrinkling. However, when power tools are not available, filler method using sand shot or fusible alloy can be used. The test is involved with quite similar regardless of the filler material. Because of the process of using fusible alloy is most complex and most accurate is presented in detail in the following paragraphs. Fusible alloy is a metal alloy with a melting point approximately 160 degrees Fahrenheit. The material must be melted under hot water near the boiling point to ensure the molten metal flows freely. Never apply the flame of the tubing or flame to the tubing or to the fusible alloy. Excess heat destroys the strength of the treated tubing and the metal characteristics of the fusible alloy. Boiling water will not melt fusible alloy the flame has been applied. Furthermore, if the tubing is held over the direct flame to remove the alloy particles in the metal can stick to the inside of the tube and cause corrosion. This shows a roller bender tool. The 6 steps taken in fusible alloy process is as follows. The coat of the inner surface of the tube is to be bent with a light engine oil specification MIL L6082. Close one end of the tube, place the fusible alloy clean steel ladle, and submerge both tube ladle in the hot water tank. The fusible alloy stays in the ladle and not combining the hot water. When the alloy has melted, pour into the tube to be bent, keeping both the tube and the ladle under the water as it fills the tube. This allows it to displace the water from the tube. After the tube is full of alloy, remove it from the water, quench it in cold water and air, cool it until the alloy is completely solidified. When the alloy is melted, pour it into the tube of the bent. Keep both the tube and the ladle under the water. As it fills the tube, allow the displacement of the water from the tube. After the tube is alloyed, remove it from the water and quench it in cold water, air cool until the alloy is completely solidified. Sorry, I guess right that over again. The tube is now solid and can be bent with a suitable bending of the tool. As this alloy bends readily when cooled, but it breaks when warm and under suddenly applied loads. Care must be taken with the alloy tube to be bent slowly. When the bending of is completed with the submerge of the tube with the hot water, allow the alloy to run out of the tube into the ladle or other suitable container. Allow the alloy must be removed from the bending of the tubing, as the alloy will cause corrosion. Also, any alloy left in the tube will obstruct the tube and alter the flow of characteristic fluids. Tube connection. There are three basic types of connections used for the aircraft tube, and the two most common are the military standard, the flareless connection, and the flared connection, depicted in Figure 2.7. The third less is frequently used for the beaded connection. Note, the Army-Navy standards designations from the government standards were changed over the military standard designations. Figure 2.7 shows a flareless fitting on the top, and this one loaded points, and a flared fitting on the bottom, with a flare line points and 1 point cantilevers. Military standard flareless connection. The connection is being used extensively for the new model aircraft. The fitting of the design primarily for the high-pressure gas liquid system for the surface where subjected to severe vibration fluctuation pressures. The connection retaining the seal under these conditions better than any of the other conditions. The military standard flareless connections consist of the connector sleeve nut, as shown in Figure 2.8. The tail of the sleeve dampens out of the tube the vibration, preventing fatigue and break while spring washer actions in the sleeve prevents the nut from loosening, keeping a better seal. The 2.8 shows the flareless fitting components as they go together and final connection. The flared connection. The connection withstands the high pressure for the use of the extensive hydraulic system. The component piece for the necessary to form the flared connection are nut sleeve properly formed with the flared tube end with the pressure. Pieces are assembled the nut and screwed with the threaded fitting of these fittings. These nuts are sleevable and are available in both steel and aluminum alloy. These varies with the material of the tube. The two types of flares can be made on the tubing. Alright, the single flares are used for all types of stainless steel tubing for the 6061 aluminum alloy tubing and the 5052 aluminum alloy tubing, largely 1/2 inch outside diameter. Double flares are specified into the 505 tubing, 1/2 inch outside diameter, smaller. The bead connection. The connection is only used with the tubing. The fitting type of the connection is not capable of withstanding the high pressure and is used only in low pressure system. No picture of beading is included here, but in Figure 2.12, which illustrates the low-pressure tube splice, shows an example of the beaded connection. Preparing tube for flaring. Two steps are used for preparing tubing, the flaring, reaming, and cleaning. They must be followed carefully with the tube is damaged, that is not damaged or weakened, preventing the foreign object damage with the tube installed. Reaming after the square cut has been made with the violations, marks, or seams or excessive graphite. Check the fitting of the mutilations to thread area and nicks. Cleaning. The prescribed cleaning tube are given in the Technical Manual 1-1500-204-23 Series Manual for the refer to the Technical Manual materials, how they are to be used by, because of the cleaning chemicals constantly improve. The improvements are incorporated within the Technical Manual printed changes. The example, the use of the solvent PS661, which has been changed to the NAFAT TT995. There's list can go on, and therefore using the cleaning agent on or in hydraulic systems, always refer to the latest applicable publication for the correct material. Use of the tube must be free of all dirt and grease before clamping the flaring tool. The flaring tool's die block must be properly cleaned to prevent the slips and deformation of the tubing. Flaring tools. Two basic types of the hand flaring tools provided with a single flare screw combination. The tools are described in the following paragraph. Screw flaring tool. There are two kinds of the screw flaring tool is one threaded with the other the plane die. The stem, the plunger on the screwing flaring tool is threaded so that its point end of the force of the tube is turning inside of the by tapping with a hammer. The screw flaring tool also have the advantage of the tube being visible so it easily determine when the flare is completed. 2.9 shows the correct, incorrect double flares. Correct, incorrect, The combination flaring tool. The combination flaring tool is designed as single flare all grades of the aircraft tubing, including stainless steel. The tube can also be double lap flare in an aluminum copper tube. The components also with the combination flare tool. The clamp blocks rotor with incorporated the punching forming double lap flares and cone-shaped punch for the forming signal flares, which each of the tool, there are two sets of die blocks each of the set. They have four accurately machined grooves to accommodate four different sizes of the tubing. The two sets of the die blocks must be able to flare 8 different sizes of the tubing. Clamp size, clamp screw is used to hold the tube between the die blocks. Compression screw is located on the front of the dial containing the flare punch. The slide stop is used in setting the top of the proper depth of the flare. Double flares. Double flares required in all 50-5052 aluminum alloy tubing less than 1/2 inch of outside diameter. Double flare provides a double thickness of the metal and the flare itself. The double thickness reduces the danger of cutting with the flare with the over-torquing during assembly. Also minimizes the danger of flare failure. Example of the correct and incorrect double flares are shown in Figure 2.9. Caution: not use flaring tools that have serrations in the clamp lock. Double flares can be formed in double F flaring tools of the shock or rotary type of the bullet by a combination of flaring tools previously described. The steps in formation of double F flare are described in following paragraphs illustrated in Figure 210. Our two shen show the double flare head process. Proper spacing between the die and block. Second, operation cone-shaped punch holes down lip into the bed of the forms of the flare, having a double thickness of the metal. First stage, punch the force down on the tube, causing bead-like swelling in the form. I'm sorry I read those out of sequence. First step, the tube is gripped between the halves of the die of the block with the end of the tube projecting slightly above the bevel of the die block hole. The first step, the die plunger is placed against the tube with the end of the tubing resting of the plunger recess. The plunger is then forced turned toward the die block, causing the bead-like swelling at the end of the tubing. The first step of the plunger is then removed, leaving the tube of the die block. Second stop, the cone is placed in the bead of the end of the tube. The plunger is forced against the bead, causing the metal at the upper half of the bead to top and the lower half of the portion forms of the flare of the double thickness of the metal at the lip. Faulty flares. Lack of care and attention to detail of the forming of the flares is likely to result in producing a faulty flare, and if the tubing is not cut squarely, the lopsided flare result of faulty flares also produced if the tube is not inserted far enough into the die block, resulting in, if under flared condition, the under flared tubing has a small gripping area, will pull apart under the pressure if the tubing is inserted until it produces too far past the edges of the die block. Over flared condition result. This can cause the flare to crack or break. Using stop to prevent this type of overflare. Too much force using the forming tool when making the flare result is in cracked or flush flare. Cleaning tube. After the tube has been formed or flared, all oil and grease or other formed material must be removed before installing. Remove every trace of the oil and grease of the oxygen tubing and the material critical importance because of the contact between the bottled oxygen used for the breathing, oil and grease, the result in the spontaneous combustion explosion. Plumbing fittings. Fittings are used to assemble interconnects, tubings, hoses, and plumbing components in the connecting lines. Through bulkheads. Example of these fittings are shown in Figure 2.1. Prior to the installation, all the fittings must be carefully examined to ensure that the surfaces are smoothest, but consist of the freedom of the birds, nicks, scratches, or tool marks. Following inspection of the fitting of the thin coat with the anti-seizing compound Federal Specification TTA580 must be applied with the three threads of fitting exact hydraulic oxygen fittings. Hydraulic fittings must be used to lubricate the fittings of the hydraulic plumbing lines. Anti-seize compound MEL T5542 is used to lubricate the fittings of the oxygen system. Fitting nuts. Aircraft plane check nuts are used to secure the tubing and the fitting. Assemble the two together to connect the entire tube assembly component of the plumbing of the system. Only special fitting nut wrenches the torque indicated should be used with installing the tube. The assembly, if not available, the open end of the wrenches can be used. The tightening of the fitting nuts to the proper torque during the installation is very important. Over torquing these nuts can be severe damage to the tube flares. The sleeve of the nut. Under torquing is equally serious. It can also allow the time to blow off the fitting of the leakage. Under pressure, when the fittings are properly torqued, the tube assemble can be removed and installed many times before the reflaring becomes necessary. When installing a fitting through a bulkhead, take care to ensure that the nuts are tight enough to prevent any of the movement between the bulkhead and the fitting. If any of the movement that take place in the vibration cause fittings to enlarge the hole through the bulkhead beyond the tolerance of the damage of the fitting. Cautioning a fitting must never be tightened when there is pressure in the system, as this results in under torqued condition and that tends to cut the flare. Installation of tubing assembly. Before the tubing assembly is installed with the aircraft, it must be carefully inspected. All dents and nicks must be removed. The sleeves must be snug fitting of the 1/16 to 1/8 of an inch of the tube protruding above the top of the sleeve. The line assembly must be cleaned free of all foreign matter described in the earlier paragraph. During installation, the fitting of the nuts must be screwed down by hand until the seat is then properly torqued. The tubing the assembled must not have been pulled into place with the nut or before but must be aligned before tightening. 211 shows typical fittings. You have your adaptive flareless tube and flared tube, adaptive flareless tube and bulkheaded universal flared tube, union flareless tube, bulkheaded universal, elbows 90 T cross, elbow flareless universal 45 degree, elbow bulkhead universal flareless double flareless tube, T bulkhead universal flareless tube, T flareless tube internal thread on run, tube flareless tube internal thread on run, T, flareless tube on bulkhead on run, flareless tube, cap pressure seal, careless tube, seating, fitting, brushing screw, thread, expanded flareless tube, the connection, and reducing external thread, flareless tube. If the tubing is run through a bulkhead instead of the being connected through the bulkhead of the fitting, take extra care so that the tubing is not scratched. For the adding protection operation, the edge of the cutouts must be taped before the tape line is installed. The tube repair. Large percent of the minor damage of the aircraft plumbing is a result of a careless maintenance practice. Misplaced foot or tool can scratch, nick, or dent the tubing beyond the tolerance. Therefore, caution of the part of the maintenance personnel can prevent a great deal of work. When damaged tube is discovered, the ideal solution to replace the complete section of the tubing. In some instances, however, this may not be possible. In the case of the minor damages, can usually be repaired provided with the damage or within specified limits. Minor repair techniques are described in paragraph that follow. The dents. Any dent less than 20% of the tubing diameter is not objectionable unless it is on the heel of the short of the bending of the radius, in which case the tube is discarded. Dents exceeding 20% of the tube diameter must be replaced. Burnishing is not allowed to heal the bends with the material as already been stretched in during the forming. Next, any piece of the tubing subject to the tube with the flaring because of the stress of the concentration will cause the vibration at the point of the nick. The nicks when weakening the tube against the internal pressure for the such that the nicks must be burnished out to reduce the notch effects. The nick no deeper than 15% of the wall thickness. Aluminum alloy, copper, steel tubing must be reworked. Burnishing the hand and tools. All aluminum alloy, copper, steel tubing with the nicks excess of 15% of the wall thickness should be rejected. Tubing with the nicks in a bend that should be replaced if it is carrying over 100 psi pressure. The tube carrying pressure of 100 psi or less. No nick deeper than 20% of the wall thickness for the aluminum alloy, copper, steel may be reworked by burnishing with hand tools. Splicing. When the tube damage exceeds the tolerance repair described in the preceding paragraph, when it is not possible to replace the entire section of the tubing, a splice can be reinstalled. Therefore, different methods of splicing damaging tube is one for repairing low-pressure tubing, other for repairing high-pressure tubing. The steps involved in each of these methods are shown along with a graphic illustration on the process. Figure 212, the lower-pressure tubing. Figure 213, high-pressure tubing. Whenever this type of tubing repair is used, particular attention must be paid to ensure the compliance with the tube tolerance and tube torque limitations of the clamp connections. Alright, 212 shows the low pressure tube splices. High pressure tube splices. 213. Some of these, there are three types of metal tubing used in the aircraft plumbing system: aluminum alloy, stainless steel, copper, aluminum alloy tube, the most widely used to cover the workability, resistant corrosion, lightweight. The stainless steel tube is used in high pressure systems in place where the tubing is exposed to possible flying object damage and ground handling mishaps. Copper tubing is normally used only in high pressure oxygen systems. En route of replacement lines, the path of the original line is usually followed. However, with a different route must be used. The care must be taken to plan the layout to ensure that the bends in the tubing do not exceed the minimum bend of the radius specified with the particular tubing. The type of the tube carefully must be taken not to route that the tubing without bends. This allows for no flexibility in response to vibration or pressure fluctuations. The Army has two acceptable methods of tube cutting. The most accurate and commonly used is the standard tube cutting tool. Properly used, the tool leaves a smooth end of the tube, the square of the axis. The second method of tube cutting is using fine-tooth hacksaw. The method does not provide a square cut, but produces the standard cutting tool necessity filling the tube after the end of the cutting of the square off the ends. A variety of the tools methods are available for tube bending. Each have the capabilities and advantages applicable to the particular type of the side of the tube. Regardless of the method used, the object is to obtain a small even bend without flattening the buckling. Are the two most common type of the connections used in the aircraft tubing: the military standard flareless and flared connection. The military flareless connection has a distinct advantage of the flared connection. It is easier to construct with the three loaded points to prevent leakage, as opposed to one flared connection. Any can be used many times without danger of cracking. Flare connections are formed by many means of flaring tools. When properly formed, they are capable of withstanding high pressure and extensively in hydraulic system. One of the two kinds of the flare can be depending on the type of the size being used. Single flares are always used. All sizes of the 505 aluminum alloy tubing with outside diameters greater than 1 inch. Double flares are used on all size tubings with an outside diameter of 1/2 inch or less. The third type of the connection used for the aircraft plumbing is the bead connection. This type of the connection is not capable of withstanding high pressure and is used only in low pressure systems. Fittings are used with the aircraft plumbing system to connect the various lines with each other and with the components they operate prior to install. Fittings must be inspected to ensure they are all surface smooth and they can be located with appropriate lubricant. Fittings must always be tightened with the torque indicating wrenches to ensure proper seal. Over-torquing these nuts can severely damage the tube assembly. Likewise, under-torquing can allow the line to blow out the fitting of the leakage under the pressure. The damage of the tube is discovered. The ideal solution to replace it. Complete section of the tubing. When this is not possible, minor dents and nicks and scratches can usually repaired by the damages or with a specified limit. If the tube damages are extensive and exceed repair limitations, the tube splice can be installed and temporarily repair measurements. Part B, hoses.